Hi, 8th grade, Mr. Pastel here. Today I'm going to guide you through lesson 2.5, reflecting on differences in body structures. So let's go to the warm-up. Okay, in the beginning of this warm-up, we have to put these events in the correct order. So, first question, do we start with the ancestor population or the descendant population? That's right, we start with the ancestor population. So I'll move these to the top. Descendant populations on the bottom. Now, which of these ancestor populations comes first? First, you have an ancestor population in a stable environment. Then something happens, let's say there's a flood or some other kind of event in the environment where the ancestor population gets separated. Maybe there's just somewhere that part of the population migrates to. So let's sort the end of this. So what's going to come first? Descendant populations being similar or being different? At first, they're going to be similar. But as time passes, they're not going to breed with each other. So they're going to become different because they're in two slightly different environments, or very different environments in some cases. So it takes time to build up big differences. Later in today's lesson, you'll have the chance to answer a question. Actually, we're not going to do the end of that because we don't have enough evidence really. But we still are going to answer this question here. How did wolves, whales, and the mystery fossil become so different from their common ancestor population? So let's use some of this information that we have up here. Maybe we can say something like they started out. Like their ancestor population, but what? What do you think? But they got separated into different environments and gradually evolved different structures. Something like that. You add your own flavor to that. Okay, part 2. We're going to open a model. Okay. Let's deconstruct this here. So we have an organism here, and it branches into 2 different environments, so similar to the warm-up. So we know that this is an ancestor population. In environment A, what is adaptive? Longer tails and thicker backbones. Longer tails and thicker backbones. So it's going to take some time to get to longer tails and thicker backbones, but let's find the organism that's going to evolve eventually. So longer tails and thicker backbones. It's got a thick backbone but not a long tail. I think it's this one, longer tails and thicker backbones. So I put it here because it's going to end up here eventually, not immediately. And let's look at environment B. Eventually we're going to reach larger back limbs and larger front limbs. These are both pretty big. Yeah. Now the harder part, we have to get kind of the intermediate structures, the things that get us to the end. So let's see, let's go back to A. A somewhat thick backbone and a somewhat longer tail. I think this one. Yeah, the backbone's a little bit thicker and the tail's a little bit longer. And the intermediate structure here, slightly longer limbs. So I think it's this one. Let's double check. Yeah, the back leg is a bit longer. The front leg is a bit longer. So hand that in. Okay. How does this model show how species share a common how does this model show that how species share a common ancestor can become very different from one another? Well, they're separated into different environments, and furthermore, it takes time to develop different structures. So I would say different environments and a long amount of time. What remains stable over time in your model? What changes? The skull did not change, did it? There was no reason for the skull to change at all. So what changed was the front limb, the back limb, the backbone, and the tail, depending on the environment. But the skull never changed because I had no reason to. But everything else changed. That's it for today, actually. So next time, I believe we'll be doing a critical juncture assessment.